Hello, good evening. My name is John Dampil from the Polytechnic University of the Philippines, taking the program Master of Science in Computer Engineering. And tonight we will be conducting a scientific paper review for the study entitled Expert System for Security Audit using Fuzzy Logic. Now, moving on to the research order, there are three researchers here, and they are all from the Kazakh British Technical University, and they are K. Kozakmet, G. Bortsova, A. Inoue, and L. Atimtayeva. So there are um, four researchers for the study, and the goals and objective of this is to utilize a fuzzy logic-based expert system that can be used to analyze and determine the data when performing an IS security audit for an organization. Now, basically, for an organization, any company, regardless of their business and their field of expertise, a security audit or an information system security audit is always required, as this is mandated and it should be part of their compliance. And a security audit contains the vulnerability list for their company, for their hardware, such as their servers and their computers, making sure that the IDIS team of that particular organization are addressing them, such as via vulnerability remediation and patching. And this ensures that whatever happens to the organization or whatever malwares that were introduced into the organization, the infrastructure is still safe and reliable. So, an expert system, or an ES, is a computer system that emulates the decision-making ability of a human expert. That is based from Jackson, 1998. And basically, an expert system is what we use to emulate, like, what will be the decision-making ability. It's a system or a computer system-based tool that can simulate or emulate a human, the ability of a human on how to create decision making based on inputs or based on input variables that we have. So there will be these circumstances, and this is based by if-then rules. So if this is if this, then that. So that's how if-then based rules. So basically, an ES helps us on how to create decision making that is derived or that is based on human behavior. So with the proposed system, its main objective are as follows. So it will be reduce cost, simply because you won't, if you have an expert based system utilizing fuzzy logic to determine the security audit, you will no longer have to hire multiple staff to perform this, so it will be a reduced cost. Increase the availability since it's easier to deploy. Multiple expertise since you can apply this to different systems and also different organizations. Time saving simply because it's already an automated system that's performing the action, so there's less room for human error, and at the same time you won't have to commit errors along the way that requires correction at the end. So it's basically saving a lot of time for the internal ID team or for whoever is performing the audit. Steady and emotional and complete response at all times. So this is one of the most important. So basically, there are no emotions involved when performing the audit. It's steady since it's a computer-based system or automated system, and at the same time there will be no bias on the results. So we are sure that whatever is stated on the result or final documentation, everything is correct and properly interpreted. So the methodology or the data gathering techniques that they use is that they gather the data by means of performing a qualified security estimation. They have decided to follow the thinking pattern of security editors and define the assets of the organization, vulnerabilities that may exist, threats, particular harm could be inflicted to them, and also consider the impact of those threats. Now, basically, the researchers have analyzed multiple documentations by exploring how security auditors behave, and from there they have derived their own system from those behavior that they can observe from security auditors, like how they answer questions, or how they address a particular compliance report based on security vulnerabilities. So they have utilized those facts, as mentioned here, the pattern of security auditors and vulnerabilities that may exist, what are the threats, what are the particular harm, etc. With this approach, the researchers were able to simulate the decision makings for IS security audits, and from those input variables that requires decision making, they have applied fuzzy logic to eliminate the fuzziness and create some well-defined output by declaring multiple rules that will defuzzify the input variables. So for every circumstances that they have, depending on the facts that they have gathered, they were able to use fuzzy logic to apply and eliminate the fuzziness, and came up with a table or a easy representation of how they interpret those details and how they create decision or well-defined and concrete output based from them. So for their data processing, the researchers have identified what are the assets that are required for an IS security audit, mainly physical assets. So these are the computers, the servers, basically these are the hardwares or the tangible objects that that a company possesses. And informational assets, so typically these will be the information of clients, such as their databases, their active directories, their user profiles, and everything, which are to be protected. So because the possibility of something to happen, especially in an IS event, it is very hard to evaluate precisely, as it should be represented as fuzzy term. In order to calculate overall possibility, all factors impact should be taken into account. Now what does that mean is that for every IS related, since most of the time it's confidential information, so we cannot just consider physical assets as the primary aspect for any security audit. And at the same time, on the other hand, we cannot just consider the informational assets as the important ones, because they basically have to have a chemistry with each other, or should I say consideration with each factor, or which with each assets that needs to be defined and evaluated, and for us to be able to apply fuzzy logic and get those decisions that we make. So for example, if the computers are patched, or if the servers are patched, we cannot just consider, or we cannot just decide that my organization is secured. We should also consider how the employee information or databases are exposed, or are they even vulnerable to attacks, because no matter how, for example, no matter how your servers are patched or secured, if your employee information are not protected, then there's no sense at all. So it is not balanced, or we cannot consider it secured. Same with vice versa. If your employee databases are locked or authenticated, but your servers can be easily hacked, or can be easily penetrated or infiltrated by malwares and hackers, so there is still less protection. So that's what the third line means. So all factors impact should be taken into account. So this is the table. So on the left we have the physical assets. So what are the possible vulnerabilities for them will be poor physical entry controls, inadequate equipment, turnover rate on position, employees' background check practice. So for the information, we have the user access, lack of operational software control, employee security and awareness, audit logs, user password management, system administration qualification, experience, knowledge level, and negligence. So this is like a representation on how we should consider, or how we should factor in each facts, or each factors that can affect those assets that were defined in the previous PowerPoint slide. So once they were able to process the data, they have considered the two main factors, which is the negligence level, and the second one is the password strength. So on the left is the graph. I believe this might came from MATLAB. So they have considered entry numbers 0, 1, 2, and 3 as low negligence, 2, 3, 3, 4, 5, 6 as moderate negligence, and 7, 8, 9, and 1 as the high negligence, and also for the password they have three values, which is weak, good, and strong. So they have created the table below, which or on the right side, and below are the rules defined on how to represent the table. So for example, if your negligence is low, if our negligence is low but the password is strong, then we have high security. So same goes for the other rules that were defined from here. So from this table or representation, they were able to defuzzify the fuzziness or remove the gaps or impreciseness in the input variables that they have. So technically they have considered both factors, which is the negligence and the password strength, for them to came up with a decision-based answer or decision-based output, which is supported as well by facts and a representation of all the data. So their study findings is that the researchers were able to determine the importance of fuzzy logic and that its flexibility can be applied into information technology, particularly in the field of cybersecurity and security auditing. Fuzzy expert systems applied to information security field is also a sufficient technique for emulating specialist decision-making ability. Fuzzy expert systems also have the advantage of allowing rules to be written in common language rather than technical jargons. As a consequence, communication between the domain expert and knowledge engineer is greatly simplified. So with this study, they were able to prove that a fuzzy expert system can have a major impact on how security audits are done. Also, it allows the rules to be written on an easily understandable representations, such as on the previous slide, let's say if negligence is low and the password is strong, then the password security is high. So they created multiple rules that basically everyone can easily understand and digest on how they are represented. So as a consequence, the communication between the domain expert or from the security auditor's perspective and the engineer who is supporting the audit is greatly simplified. So from there they can easily interact and came up or study, or should I say examine the findings that they have.